Today we discussing about the topic is equipotential surface. Equipotential surface. Now, equi means equal potential of a surface. That means let us consider this is the electric field. What is considered as an electric field? Uniform electric field. What is considered by the uniform electric field? In electric field, we are considering by the points. This is the one point, this is another point, this is another point, this will be the consider. These are different points are we are considering by there. Now the different point for the all points, here, any one we take, that potential will be equal. Potential will be equal the surface of a electric field. See, that is called the equipotential surface. That means the locus of all points. See, the locus of all points which have the same electric potential, is called equipotential surface. Means we take the any point, that potential will be same. That is called as a, what is called as an equipotential surface. Now here the work done by on a equipotential surface is equal to 0 because of there is no work done, the constraint by any equipotential surface. Now we discussing about the properties. The first properties, as the potential difference between any 2 points on the equipotential surface equal to 0 because of, now the first point how much of the potential will be there, the second point also will be same, then the difference of this is A point, this is the B point, the VA minus VB is equal to what will be there, is an equal to 0. There is no potential difference will be there any 2 points. The next, electric field is always, this electric field is always the perpendicular to the equipotential surface. See, that means here this is the perpendicular to the equipotential surface. Now the third point, at any point on the equipotential surface, the component of electric field, the parallel to the surface is 0. So what is that? At any point on equipotential surface, of electric field, the parallel to the surface is 0. This is the third property. See now the next, in uniform field, the line of force, this is the, you consider the uniform field. In line of force, the straight and parallel, and the equipotential surface, the perpendicular to the line of force. See, this is the straight lines. This is called the electric field line of force. Where is taken by there? In a uniform electric field. This will be in a parallel. So what is it? This is in a parallel. But here the surface, this is the perpendicular to this one. This is called the line of force, the perpendicular to the equipotential of the surface. Now this is the fourth property. Now in a fifth property, see in a the charged sphere. So what is taken by in a the charged sphere, the uniformly distribution. See, this is the charged sphere. This is the equipotential surface, can be dividing of a equally to the at every point. This is the charged sphere. Now here is the center. Now electric field lines can be dividing. This is the direction. See, this is considering a equipotential surface. Equipotential surface, and this is considered the uniformly charged sphere. In uniform charged sphere also, here the potential will be equal for the every point on a sphere. See, this is the main properties of the five properties of a equipotential surface. So next property, the spacing between the equipotential surface. What is it? The spacing is nothing but the space between equipotential surface, the enable to identify regions of strong and weak fields. The strong and weak, the which have the strong, which have the weak. See, that will say the electric field, the relation between the electric field and electric potential. What is the formula? Is E is equal to minus dV by dr. See here, the electric field is inversely proportional to the distance. When the distance will be increasing, the electric field can be decreasing. The distance will be decreasing, the electric field region can be increasing. Now let us, we are considering the example we can see here. See, this is the one of the equipotential surface at 40 volts. Now here is considered the P point. What is considered this a P point? Now next we are considering this another of the equipotential surface. It is given by the 30 volts. Now here is considered the Q point. What is considered this a Q point? And next we are considering by the 20 volts. And here is considering the R point, and it is the 10 volts. Now whichever is there, the less is there, here the distance will be very less. That means the distance will be decreasing, the electric field can be increasing. Here the distance will be increasing. The distance will be increasing means the electric field can be decreasing because of it is the inversely proportional. Now we can write the electric field at the P point and electric field at the Q point and electric field at the R point. See, that will say the electric field, the P is less than of electric field of Q is less than of electric field of R. That means the electric field R is more the compared to the Q and P. Because of here the distance will be increasing, the electric field can be decreasing. This is the one of the example for the, this is the when the space between, see this is the space between the electric potential and the region, the strong to weak. The strong to weak. For example, it is a, this is a, what is the uniform electric field. In non-uniform electric field again, so that is one of the condition. Is taken a non-uniform electric field, these field lines are not parallel. The field lines are not parallel. When is there only the uniform electric field, the electric field lines of force will be parallel. In non-uniform electric field, the field lines are in a not parallel. That means the equipotential surface is not constrained by the position. See, this is the properties of equipotential surface.